Hello. Tried recording this on Friday, didn't really work, so I'm just giving it another go because really hope you guys watch this one if you missed out on Friday's lesson, because this content is really important. So today, got a little bit going on. I've actually written down our learning intent and our steps to success and our success criteria so you can kind of know where we're going. All right. So our learning intent today is we're going to be looking at how to calculate the midpoint and the distance between 2 points. Okay, we're going to do that both graphically, alrighty, on a graph. We're also going to do it when we have just points given. So when we have just points like this, all right, these formulas kind of help us for when we don't have the beautiful things on our graph, and we'll kind of go into that in a little bit more detail shortly. And then at the very last part of the lesson, we're going to do a little bit of a review to make sure that we have met our success criteria, okay? Because our success criteria tells us by the end of the lesson, we need to be able to recognize and identify what each of our formulas are and what they're used for, okay? Once we make sure we know how to do that, you also need to be able to know that you can actually apply those formulas, okay, to be able to calculate the slope, the midpoint, and the distance with those formulas, okay? So that's why right at the very end of this, you'll see that I have a cool little exit ticket where you'll have to figure out what each of these formulas are used for, and then just a little bit of reflection. Cool. So let's get straight into it. I've also sent through this slope worksheet, so you can print it if you have a printer, or you can use it, open it up on your iPad if you want, if you have an iPad to do it. Else you could just, I suppose, look at it through your phone and just do your working out in your exercise books as we follow along. Okay, so this question, what you always need to make sure you do is you read the question. And I know that sounds so simple. You're like, yeah, miss, read the question. But it's so important because that question is telling you exactly what you need to be able to do to succeed in that. And so many times people just look at it and they say, oh yeah, I see some points, I see a line, you want me to do whatever, and they just assume, okay? But if you make sure you carefully read what the question is telling you, it'll give you those directions to make sure that you are doing what you need to be doing in there, okay? So if we're looking at this, it says, the question asks us, or it gives us directions to find the slope, alrighty? Find the slope of each of these lines. And we know that our slope, we know that our slope is equal to m, okay? And we're really familiar with that slope. Ooh, I actually don't like that pen, it's too big. We know that our slope is m, okay? That's what we write slope for. We know that our slope is, we can also write it shorthand for m. That's what we use it in all our calculations, lower case m. And we know, and we've seen it many times because we put it in our formula, don't we? y equals mx plus c. And so that m right here is the coefficient of our variable, of our x variable. So again, that will tell us how steep or shallow one of the lines is. So how steep, whether it's going really up high, or whether it's really shallow and slow like this, or if it's going up in an incline, or if it's going down like this one, declining. So that m will tell us a few of these things. We can give it a numerical, a number answer to help us, okay? Because that will give us a bit of information. So we know 2 different methods of doing this. Alrighty, and so we're going to practice both of those two methods now. If you are following along at home, which is probably the only way you will be doing this right now because I'm not recording live, well, like as in a live lesson, but what I'd suggest is you just pause this for a moment and give yourself a little bit of a go to see if you can calculate that slope yourself. All right, there will be two different ways, and I think I mentioned it a second ago. Is it bad that I can't actually remember? But pretty sure there's two different methods that you can use to try this. I'm going to cut this whole part out. So looking at your slope, alrighty, the question is asking you to calculate the slope of each of these lines here. Alright, calculate the slope. Calculate the slope of each of these lines. We know our slope is equal to m. Alrighty, so let's begin. Now, this is going to sound really, really silly, but the first thing I want you guys to do whenever you look at any sort of question, alright, especially on our exams, I really, 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 really want you to make sure the first thing you are doing is actually reading what the question says, okay? I know you're like, oh, Miss, read the question. But no, seriously, the amount of times I see people who just look at it and go, oh, yep, no worries. I see this as a graph. I guess you want me to do this. You want me to calculate the equation, or you want me to tell you what the points are. Then they just guess, okay? So the problem with just going and guessing and showing me what you know is I can only mark you on and give you points towards your grade for if you have actually shown me and answered what this question is telling me, okay? So, first of all, I want you to really closely read the questions and find out what is it asking me to do. So if we're looking at this question here, it says find the slope of each of these lines. Okay, so we've done a whole heap of practice about slope so far. We know our slope actually is, we can write it and display it with it's symbolically as m. Okay, slope, lowercase m. Is that clear that that's a lowercase m? There you go, lowercase m. Okay, we've seen this lowercase m as around the place heaps of times. We've used it in our equation of our straight line, y equals mx plus c. Okay, so we've seen this bad boy around. We know that this is our slope here algebraically, symbolically what this is, and we know what this actually represents. We know if we're looking at it graphically, this is showing us how steep our line is, yeah? How steep this line is, whether it's inclining or whether it's declining, going down, okay? If it's super, 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 super steep, or if it's kind of like just really, 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 really flat, nearly completely straight on the bottom, but not quite, just a little bit up. Oh, that doesn't really show, hey? So that's what it tells us. And this knowing exactly what our m value is, whether or not m is going to be, say, if m is going to be positive, all right, if m is greater than 0, we know that it's positive, it's going upwards, okay? If m is going to be less than 0, so if it's a negative number, we know negative going downwards, okay? So just by understanding our m value, finding what m equals, even if we didn't have this graph, we would kind of be able to picture and understand, okay, what's happening around here? And this is really important because it'll help us later on down the track figure out and understand what's happening when we apply these kind of formulas when we're investigating real life scenarios. And I know it all sounds really abstract and strange right now, but it will make sense further on down the track when we're starting to apply some of these things. Alrighty. So what I want you to do now, I want you to pause this and I want you to give it a little bit of a go. There's 2 different methods you can use, okay? And I don't mind either method. They both will give you the exact same answer. And if you're not quite sure what those methods are, that's okay. Where can you go to find it? Could you look in your Cornell notes perhaps? Go back through. Have a look at those working out examples that I've done for you guys and I got you to copy down in your exercise books. You could also go and have a look at the parts you're working where you've practiced this yourself. So I want you to pause it. I want you to give it a go. And then once you've done all 4 of these, I'll go through and I'll show you a couple of those solutions for each of those methods. All right? Cool. Alrighty, welcome back. I'm assuming you've gone through and done this, and I really hope you have. I hope you haven't just gone, yeah, miss, totally. I'll totally do it, and then just continued playing, because not cool if you did that. It's not cool. Doesn't help you. Remember what I said, listening and watching, it's only 40% effective of your learning. Most of the learning comes from doing it yourself, okay? So make sure you're doing it. So, finding the slope. We know how to do and calculate the slope 2 different ways. Alrighty? I'm going to do, the first way I'm going to do it is I'm going to do it using my graph and just having a look at it graphically, and I'm going to look at those cool things with our formula, which we started off learning with it, which is our slope or our gradient is equal to m is equal to rise over run. Slope, it's the rise over the run. The distance. Okay, I'm not going to do that, but I can link that song. Actually, I've linked you it. So our rise is when we're going upwards, okay? And it is actually the very specific value that we get when we go from our bottom point all the way and we're rising to where we are in line with this top point here. All right? So we're going to have a look at and check, okay, how many points did we go up? And then our run will be this part here. And you're going to see, okay, how many points from our initial point to our second point, how many did we go across to get it? Yeah, to get to it. I like joining them up like this so I can make a cool little triangle. I like triangles. But these will help us later on when we're looking at our distance formula. And because we could recognize our little Pythagoras. But again, we'll talk about that later. Don't get ahead of yourself, Miss Page. This first method, using our rise over run, this one here, super duper easy. All right, it's as simple as having a look and going, okay, rise, which is our y value, rise, how much is it going up? All right, how much is it going up? How far is it from this bottom point to vertically to this top point along here? This is our rise, all right? Rise. And then our run is how far across is it? So if we're looking at here is where we started out at the beginning in our first point, and how far across did we go to get to our second point? How far across All right, did we go? That's our rise, that's our run. Now all you need to do is actually count between them. Okay, how far did I go? Easy peasy. All right. This method is best when we have our graph. Unfortunately, if we get questions where we don't actually know the graph, we can't see it, we're not given it, we won't be able to use this one. So that's why we use the next formula that we'll do in a moment. But for now, let's just do this. All right. So looking at this, all we need to do, really easy, let's count this. So we started at, I'm going to move this out of the way so I can kind of have a little bit, actually no, I'm going to bring it back. I'm just going to delete these little bits here so I can kind of see what's going on. Oh, you know what? It's gone. That's all right. So having a look at this, we're going to say how high up did we go? So our rise, we went from here up to here. And how many is that? That's 1, 2, 3, 4. 1, 2, 3, 4. So we know that our rise here, from here to here, our rise is 4. Easy. Now we're going to do the same for our run. So from here to here, how many across did we go? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So we know that number across here is 9. That looks like an A, doesn't it? Move this out of the way. And we'll write 9 here. Alrighty. Look at that. Nice and easy. So now all we need to do is we need to get that number. We go back to our formula, and we just throw those numbers in. Alright. So we know M is equal to rise over divided by run. We know what our rise is. We've just found it. It's 4. It goes up 4. And we know our run is 9. So we're just going to replace rise with 4. We're going to replace run with 9. Super easy. Let's do that. So M, I'm going to zoom it in a little bit. M is equal to our rise, which we found was 4, divided by our run, which we found was 9. Alrighty. Now, we want to simplify this fraction. We know that 4... Actually, we can't simplify it. What are you talking about? That's our final answer. Cool. You can put it into your calculator, get a decimal. I hate decimals. Please don't. Just leave it as it is. All right? You won't get extra marks if you go to decimals. You won't get marked down if you do leave it in a fraction. All right? So that's it. M is equal to 4 over 9. Ta-da! Yay! Yay! Finished. All right. I might quickly do this one over here so you can mark yourself here as well. I won't talk through. You can just have a little bit of a watch. Give my voice a little bit of a rest. I could simplify this further to 1.5 if you wanted to. Again, I'm happy to leave it as this here. It doesn't really bother me all too much. However, you want to leave it. Again, I like fractions, so don't worry too much if it's not in a fraction. All right. So that's those two methods there done. Nice and easy. Sometimes we're not given our actual graph. Sometimes we don't know what that graph is going to be, and we don't know, we can't see it, we can't count it, and sometimes it's really, really far away. We might have a point all the way down here, and then another point all the way up here in this line, and we don't know what they are, and it's going to take 1,000,000 years to graph it. Oh gosh, that's so annoying. Then I'll be counting for like 1,000,000. Oh no, that's too much, way too much. But luckily enough, I know if they tell me what those coordinate points are, they tell me what I'm looking for those 2 points in the middle of all the way nowhere, all right, I can easily put that into a formula. Now we know what that formula is, and hopefully you guys have just gone back through and looked in your book to find it, but I'm going to write it down now really quickly. So m is equal to, now this is because it's rise over run, we're going to do our y first. All right, on the top, not our x. I have noticed a couple of you guys accidentally putting your x on the top, which is a really easy mistake to make, because I'm always like, yeah, do x first and then y, but that's when you're writing it across like this, all right? But remember, rise is your y value, how much you're going upwards or downwards. So that's why we do our y first. So looking at that, we know our y, which is our change in y, how much it changes, is equal to y2 minus y1, all divided by our run, which is, when our run, when we had a look at it earlier, it's our side by side, and that's on our x, our x-axis. So we know which seeing at how much did our x value change from here to here. How much did it change? How much did it go up or down? We counted that, so that's why we have our change. So we're going to calculate that from looking at our x value. So where we started minus where we are. Okay? Alrighty. Fantastic. So we know that. That's nice and easy. That's our formula. If you are in your exam, you'll be given this formula, okay? You'll be given it, and you will actually not need to remember this off by heart. You just need to be able to go, oh, I can see m equals blah, 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 all of this. I know this is a thing to help me find out what this slope is, all right? So you don't need to remember that. But you do need to know how to use it. Now, there's a whole heap of things. We got the y2 and our y1. All right, we got our x2 and our x1. Right now, these are just standing in place for what it will be. We don't know what it is. This is why we have a formula. So to be able to figure out what we put in here to get our specific answer of m, well, don't we need to find these points first? So let's do that right now. P1 is going to be open brackets. Now remember, we're going to go our x and our y. So counting across how many x's. So this is, if we're going in this direction, we know this is going to be negative. So let's count this. So this is 0. So we're at -1, -2, -3, -4. Okay, so -4 across. Now we're going to see how many it's going to be in our y. Okay, we know our y is up. So our y part, so how much is it up? So 1, 2. Okay, so I'm just pressing buttons unnecessarily here, aren't I? There you go. That's our first point. Now I'm going to move it a little bit closer because it's a bit wild. All right. Now going to have a look at the second point here. I'm going to this point over here. I'm going to name this one P2. All right. And noticing, I'll make it really clear over here, that P just means P for point. P for point. All right. And 1 just means it's the first point. 2 means it's the second point. All right. And we just write it down as little numbers down here because it helps us know that that's not P times 1. All right, because that'd confuse us. So we write little numbers to know, okay, this is a second one. This is a second one. This is a first one. So we know what our first one is here. Now we're looking at our second one. All right, that's why we got that little 2 here. So let's actually find out what this coordinate point is. So let's have a look. We're going to need to count our x's across first. So 1, 2 in the positive direction. Nice. 2. Oh gosh, I've got all this stuff here. Let's move this out of the way. Rub this out. All right. Now we're going to see how many across, up or down in our y axes. So downwards, negative, -1. Ta-da, done. We've got our 2 points here. We need to figure out which one, because we need to put these numbers here. We're going to put those numbers into our graph that we have over here. Okay, not our graph, our formula. All right, so we need to figure out, okay, which one is y2? Which one's y1? What about x2? Okay, so remember these little 2 means second. This one means first. This is our second one. This is our first one. So we're going to need to split them up, aren't we? So let's try and identify this first, okay? So y2, all right, y2, this bad boy over here, our y2, 2 means go to your second point. 2 means go to your second point. So this is our second point here. So now I'm going to go into the y part of that one. So we know that, I'm going to write this up here so I don't forget. X first, then y. All right. So our y2, so if this is our x, this will be our y. So this part here is my y. This is always my y on this other part. So that's my second part. And then, so I can write that down. So I might actually do that so I don't get ahead of myself. M is equal to y2, which we just said was -1, -1. And I don't like having those colors because that doesn't help me. There you go. Minus y1 here. So 1 means our first point. So we go to our first point here. And we go to our y value. We know x first and y, so x and then y. So our y2, or our y1 in our first point, sorry, will be 3. So that's our 3 here. So we can write that there. Awesome. Hey, why did I put 3? I hope somebody's saying at home, like following along, going, Miss, that's not 3, that's 2. Oh my gosh, look how silly it is. Look, 1, 2. That's not 3. Lucky I found that, hey. That would have made all my answers go all weird and wonky. That's why it's important to make sure you're checking and not rushing ahead. Alright, put that number in here. 2. Alright, now we're going to do the same thing but with our x's. x2. So we're going to do a second point. And we're going to look at our x value. So this is our x here, is always our first one. So in our second point here, the first one is our x, which is 2. So we know we'll go 2 is our x2. So we can write that. And so instead of writing x2 like we did before, we're going to substitute in the value we just found, which was 2. All right. Now we're rewriting our subtract, because that's in our formula. Subtract our x1. So we need to find that x1. So going 1 means first point. going on our first point, looking at our x. You know, x was before y, so x here is -4. So I can substitute that into my equation, -4. All right, so I've got all the numbers I need to know to substitute these in to be able to work out my answer. So now is the easy part, or the part where we accidentally get messed up sometimes, is doing our actual math. And you can have your calculators with you on the exam, so you can always do the calculations in the calculator, so you don't need to worry too much about it. But I'll just work it through without my calculator at the moment. So I know if I'm in $1 debt and then I spend another $2 I don't have, well, I've made a poor financial decision, and now I'm in $3 debt. Negative meaning debt owing. Okay. Now, next part, so I'm rewriting my divided by. That's why I put that there. Now, if I have $2 in my bank account and I get rid of a debt of $4, that means I actually have $4 more, don't I? Because I'm getting rid of debt, so I have more money. Minus minus becomes a positive, yeah? This becomes a positive. So 2 plus 4 is, oh my god, what's going on with my iPad? 6. Perfect. Now, that's awesome. It's not exactly in my final form that I like, so I'm going to make sure I simplify that. I can put that in my calculator and it'll simplify it for me, but I actually realize that 3 is half of 6. So I know it's going to be a half, but I also know that it's negative, so it'll be -1/2. So -1/2. Ta-da! Look how awesome that was. Easy peasy Japanesey. So, they are the two methods that you're going to need to know how to do on your exam. You will be given questions where you will have to use this formula, all right? You'll be given a question where you're given a graph similar like this one, and you can choose to use this one if you like. You can use either method that you want, okay? But if you only learn one, I highly recommend it to be this one, okay? Because it will be the better one for you. If you want, I'll quickly answer this one over to the side here using that same method. So you can just check your answer. There's not much room here, is there? I zoom it in really close. Will it give me enough room? No, that won't. Oh well. I'm just going to do this now. Oops. And I'm going to put that into my formula. Why does that keep doing that? That's so annoying. I don't really have enough room, do I? I'll just do it over here, I suppose. M is equal to y2 minus y1 divided by 2, -3. Subtract y1, 4. Divided by x2. That's my partner singing along to cartoon music. He's so cute. Hey, how'd you get that colour? I thought I changed you. And $2 debt. I spend another $4. And $6 debt. And $2 debt. And I spend, oh no, I'm in no debt. I have $2, but then I spent $4 and now I'm in debt. But for some reason, my debt cancels out. Cancel. So I'm left with 6 divided by 2. Half of 6 is 3. Cool. Awesome. So that's my final answer there. That's my final answer. M is 3 for question 4. M is 1.5 for question 2. M is 4/9 for question 1. M is -1/2 for question 3. Cool. And we're actually expecting our answers to have those positives and negatives like they do. These ones, no, we're not. Miss Page made another mistake. Oh, she made a mistake on the one that she did here. I hope someone picked me up on this. Okay, we actually know. Hey. This isn't rising, is it? Is it? This is going down. This is falling. So this number, because it's falling, needs to be negative. Silly goose. Silly Miss Page. This number needs to be negative. So I'll move this over. Give a little bit of room to make this negative. Which means my final answer over here will be, I'll move this over as well, will be negative. There we go. And now we do expect that. That is the answer that we do expect, because we know that it's going down. And if it's going down, it's negative. Okay, this one's going down as well. So we know this answer is negative. Whereas these ones going up, we're expecting it to be positive, which it is. This one going up as well, we expect it to be positive, and our answer is. So always making sure we're going back over what we do and we check, because that's when we find the mistakes that we make. And it's okay to make mistakes. Everyone does it. Even Miss Page. So, fantastic. Thank you for joining me so far. Just to review where we are up to in our lesson. We have now done our slope practice. So we have finished our slope practice. Amazing. So now we're going to be going through this worksheet. All right, and we're looking at our distance and midpoint. We've already had a quick look at distance in a previous lesson, so this hopefully should be a bit of revision for most of you guys here. All right, so we use our distance formula, okay, to calculate the distance, right? The distance between points. You're like, Miss, you're just saying words. But I want to just draw a little, let's draw a little thing over here, right? I've got a Cartesian plane, X and Y. All right. And I've got, let's say I've got 1 point over here, and another point over here. And this formula, I use this formula to tell me how far it is. How far between this point and that part? How far is this? How far have I gone between here and here? All right. So that's why we use it. And if you remember from the other day, we can easily find that by using a really nifty little thing called, I'm going to do it this way actually, called Pythagoras. I love Pythagoras. That guy was such a genius. Ooh, there you go. Crazy genius though, hey. Ta-da! So, you guys should have seen Pythagoras before. Yeah, we got a triangle, Pythagoras. We can label this. This is A. This side is B. And our C here is C. Okay, and we know from previously that Pythagoras is the formula for that is C squared equals A squared. I might even do it in the colors, hey. Let's do it in the colors. So Pythagoras, C squared is equal to A squared plus B squared. Okay, so that's where our distance formula, that's our distance formula, and that's where it originates from. Okay, so Pythagoras gives us this bad boy to work with, and we use our coordinate points that we have. We use those coordinate points to create a formula for them. Oh my gosh, what's happened? I'm just going to move this out of the way because I didn't leave enough room for my talking. Alright. So if we bring this back from Pythagoras and we bring it back to coordinate geometry, coordinates, which we have been doing, we can actually, I suppose, show where our formula came from. So we've got A squared, which is this boy over here. We actually know what this is. We know what A is. A is our run, isn't it? I can see that. It's how far I went from here to there. We just had a look at that. So this here is our run. Alright? And we similarly, we know what this B is. We know this B is just how far it's gone up or down our rise. Yeah? Our rise. The problem with calling it rise and run is, as we saw earlier, depending on if it goes down or if it goes up, changes whether it's positive or negative, and that's really easy to make mistakes like I did, and I promise you that wasn't planned. So instead of calling it rise and run, we just call it something that makes a bit more sense. We call it the change, triangle means change, in, hey, where'd it go? Oh, there we go. We call it the change instead. So our change in our y value, how much it went up in our y, okay, how it's changed, up or down, it's changed somehow. It started up over here, then it ended up down there, so how did it change? How did the y coordinate change? Alright, then we also can then similarly write that here as the change in x. How far did it move across? Alright, how did it change? It started over here, now it's down here and it looks like it's moved that much across, all right? This is positive because it's going that way. If it was going this way, that'd be negative, yeah? Going towards the negative direction. So instead of trying to figure out, oh, is it positive, negative, is too much, is too much, we just use a cool little thing there, all right? So, triangles aside, you look really smart using those triangles, but you don't actually need to call it that. I think it's pretty easier as well if you just call it how it changes, so you can just subtract them, yeah, to find the difference of something. So let's just write this over here. Our change in x, that's just written as how the first x value changed, right? So how much the first x value changed in relation to the second value. Okay, so if we started the difference between those is just x2 minus x1. I think I explained that in the most confusing way. I'm so sorry. Similarly, the change in y is as what's happened. If you're at y2 now, you got to find out how far between it, so y2 minus y1, okay, that change. So that's where we get those two parts here, all right? We can really quickly put those into our Pythagorean theorem. So if we're having a look at this, alrighty, we have here our Pythagoras. In place of C, I'm going to write D for distance. Okay, so I'm going to rewrite this, but I'm going to call it D for distance. That's a really ugly D. D for distance. Then I'm going to write, I could write A, so A here, right, I've said is the change in y. Okay, so I could write change in y squared, right, but I don't think I'll do that. I think, because I've already found I know what change in y could be, right, I might just write that straight away. So change in y, so that's x2 minus x1. But the formula actually tells us that these are squared. All right, sorry for having them in the wrong color. So that means I need to actually square this, doesn't it? So I need to get this whole number here and square it. Oh, and d squared. Hey, there we go. What am I missing? I still need to plus b squared. So let's go plus b squared. We know our b is how y has changed, but we know that the change in y can be written as this. So I'm just going to write it that way. So open brackets y2 minus y1. Oh no, I'm running out of space. I'm just going to grab it and shuffle it along. Close brackets. Again, we know here that it's squared. So square. Alright, that's how we got here. We just want to find our distance by itself, right? We've got distance squared, but we just want d by itself because we want to know how long is this? Is this 1 meter? Is this 2 meters? Oh, it's actually not in meters, is it? It'll be in coordinate points, but we want to know how far is it? Okay, so we've got how far it is times by itself, which we don't want, we just want it by itself. So we have to get rid of this squared. And I know how to do that because we just need to do the opposite of squared. And I know the opposite of squared is square root. So let's just do that. I know that my d is equal to the square root. So I need to square root this whole thing over here. Yeah, because this is the whole d on this left side squared. So I need to square root the whole side over here. So go square root. There we go. All of this, I'm going to make a real big line because I think it's going to go forever. And then rewrite that equation. Square root of x2, how x1, how that's changed, all squared, plus how y is changed, squared. Alrighty. Ta-da! So, we know that this here is our distance formula. Alright, super easy when you actually look at it, and when you do it, right now it looks pretty crazy. And that's okay. That's alright if it looks crazy. It'll make more sense when we do it. So let's write this. Alright, let's write this all the way back into our notes here. Our formula. Oh gosh, I was writing real big, wasn't I? Let's make this smaller. There we go. Cool. So, reviewing, our distance formula is used to find the distance between 2 points, x1, y1, and x2, y2. One meaning first. So the first point, the second point. That's where we get this from. Ta-da! All right. Let's practice. So, examples. Question number 1. Find the distance between the 2 points on the graph. Alrighty. So, there's my little graph. Isn't it cute? Here are my 2 points. To be able to do that, I need to know what these points are. So, let's write this down. Let's look at our points. Let's look at these coordinate points. So, I'm going to call this one P1. So this is how many across? 1, 2, 3, 4, 5. But it's in the negative direction, so -5. And how many up? 1, 2, 3. 3 up. There you go, -5, 3. This point, my first point. Now my second point is 1, 2, also in the -2. This one's going down. 1, 2, 3. -3. There we go. Pardon me. Alrighty, got my points ready to go. All I need to do now is put them into this formula. So let's start writing these things down. So rewriting my whole formula. D is equal to the square root of, I'll do the top line in a moment, x2, so the first x point, the second x point, x2, so this is my second point, so my x here is 2, -2, sorry. Subtract our first point, this is the first point, our first xy, which is -5, close brackets, squared, plus, now I need to find my y2, so 2 going to my second one, looking at my y value here, is -3, so open brackets, -3. Oh gosh, I'm running out of room. There we go. -3, subtract our first y value, so first point, first y value is 3 here, so subtract, 3, close brackets, what are we up to, squared, all square rooted, so I can finish drawing this line here. Alright, cool. That's the hard work done, isn't it? I've figured out all my points, I've put them in. Now all I need to do is just slowly do the math. So we're looking at this, let's go rewrite. Let's say D is equal to square root. So the first thing I need to do, if I'm thinking back to BOMDAS, I might write BOMDAS over here. Hey, maybe I'll write BOMDAS. Actually, I'm gonna write PEDMAS. You're like, BOMDAS, PEDMAS? I like PEDMAS. PEDMAS. P parentheses. So parentheses means brackets. That's why we B in BOMDAS. Brackets. So I'm going to do what's in my brackets first. So to do that, let's have a look. If I'm in $2 debt, but I'm subtracting, I'm removing $5 debt, well, I'm going to be in less debt, aren't I? So if I'm subtracting a debt, that means I'm adding it. So I might just write that, right? So -2 minus means I'm getting money, right? So that'll be -2 plus 5. So if I'm in $2 debt, but then I get $5, well, I'm not really in any more debt, am I? I actually have more money. I have $3, yeah? So I can actually write that as $3. 3 squared. If you weren't sure how I did that, how I got to there, that's okay. You're not learning how to do that this term. Alright? Just put this into your calculator. Write -2 subtract -5, and I guarantee it will give you that same answer. So if you don't want to put in your calculator, just put in your calculator. It'll be good. Always check your answers as well, because that's where people make little mistakes. But it's okay if you make little mistakes, as long as you show you're working out, because then you'll still get your full marks anyway. All right, next part. Keep going, less chatting. All right, I have $3 in debt, but then I spend another $3. Again, bad financial choices. I now have $6 debt. Ugh. Squared. Alrighty. So making sure, see how I have these brackets here? It's because these were in this was in a bracket, so I put my answer in this bracket, and it will make sure that I'm squaring my -6, because that will give me a different answer in the calculator if I don't have those brackets. So making sure that you have those brackets. Okay, so let's do that. So we have done here our parentheses, which is good. Now we are at E, which is our exponent. All right, exponents. E, exponents. We looked at that at the beginning. Hey, that's these bad boys. So we're going to do that next. So rewriting everything that we have. Rewriting everything. Not changing anything but those exponents. So we can go 3 squared and put that in our calculator, or 3 times itself. 3 times 3 is 9. Plus -6 squared, or -6 times -6 is 36. And that's positive. Because negative number times a negative number gives us a positive number. Alrighty. Nearly done, aren't we? So, we have done that. Now, we need to do this part here. So, division, multiplication, well, there's none here, so scrap that. We don't need that. So, we've done parentheses, we've done our exponents, we've done our... There's no of that, so now we're on addition, subtraction from left to right. So, we just add these bad boys. So, we're going to rewrite this. Fun fact, this square root actually is like a bracket as well, but don't worry. So 9 plus 36 is 45. There you go. And we can put the square root of 45 in our calculators. I have my calculator in my school bag, which isn't on me right now. That's silly. I should always bring my calculator. Why am I not prepared for this? I'll get it in a moment. Square root of... Ooh. Hey Siri, what's the square root of 45?
The square root of 45 is approximately 6.7082.
6.082. I'm just going to go to 2 decimal places, and I know here that if I'm going to 2 decimal places, I look at the third one, and if the third one is above 5, this one goes up. So because 8 is greater than 5, I change my 0 to a 1. And that's my final answer. Ta-da! Yay! We did it. Alright. So what that tells me is that this distance between here and here is equal to, between here and here, this is equal to 6.71 units. That might be meters or inches or millimeters. Who knows? Who knows, really? Alright, that's what we do if we have a graph and we need to find it. We don't always need to have a graph though. We can do it simply from having our points, our coordinate points. Alright? And we just, if we're given those points, like we just substitute it into our formula just like we did with our slope one earlier. Okay, so I need to write my formula down first. D is equal to the square root of x1 x2 minus x1 squared plus y2 minus y1 squared, and that's all over the square root. There we go. So let's go find our points. I'm going to say that this is my first point and this is my second point. Okay, just for ease sake. So I'm gonna just start throwing everything into my formula. So x squared, not x squared, geez, x second point, so second point and my x is 3, subtract my second, our first x point, which is -4, square, plus, from bracket, our second y, so going to our second one, and our y value is -1. Subtract our y1, so our 1, our first point, and our y coordinate there. So that's 1. Positive 1. Yeah, there you go. Squared. All square rooted. There we go. Alrighty. Now we can just work it out. We've got everything in our formula and we are ready to go. So going back to PEDMAS, parentheses says I do my brackets. What's in my brackets first? So I'll do that. Brackets, so 3 minus 4, minus goes to plus, so that's 3 plus 4, which is 7. Now, -1 minus 1 is, if I'm in $1 debt, spend another $1. I'm in $2 debt now. Alrighty. P is done, so now P and dash. So P is done, now we're at exponents, sorry, our squared ones, exponents, doing these ones, so 7 squared is 49. Ooh, don't forget to write your square root, Amy. 49 plus -2 squared. -2 times -2 is +4. Sorry. Alright, now last one. Well, second last actually. So we've done that. Multiplication and division. Well, there's none, so don't need it. Now addition, subtraction. We can do the addition. So 49 plus 4 is, I'm going to do a bit of an error. I'm going to do my working out over here because I've run out of space. So D is equal to the square root of 49 plus 4, which is 53. 53. And I don't have my calculator on me either, but I do have Siri. So Siri, what is the square root of 53?
The square root of 53 is approximately 7.28011.
7.280. Into 2 decimal places, I check what my third one is. If it's less than 5, I don't round up. So 0 is smaller than 5, so I don't need to round up. That's my answer. Ta-da! We did it. So we know that distance between these 2 points, if it were, but not these specific ones, but the distance between these points here that it's given me is 7.28. Cool. Alright. I'm going to do the next one, but I'm going to do it just quickly myself. So just to show you an example, I'm not going to explain it as we go. Oh, look, I made a mistake. And you know why I made that mistake? Because I was trying to save room by not writing down the formula, and it backfired. And I forgot which one goes first. So I'm just going to write down that formula so I can see what I'm doing. It's directly in front of me and I don't accidentally muck it up. Square root of now I can have a bit of a look and substitute these things in. Cool. Ta-da! Awesome. I want you to pause here for a moment because there are some worksheets. There are some questions in the worksheet that I want you guys to do. Okay, so pause the video here. All right, get that worksheet with the riddle. All right, and read the questions. There's some questions which specifically ask you to calculate the distance. So go practice a whole heap of those. If you need to look back and check these examples, you totally can. That's all good. All right. So have a pause and then continue on shortly, and we'll look at the midpoint. Alrighty, welcome back. I'm so glad to hear that you had paused that video and you practice a whole heap of those distance questions. You're feeling confident and you're ready to learn some new content. We're going to look at our midpoint now, okay? We're going to look at midpoint and we're going to look at what that is. What is a midpoint? We're also going to look at, okay, if we what's the easy way to find it, and we'll figure that out via the use of a formula. Okie dokie? So by the end of this little part here, you should feel really confident in being able to find so identify what the midpoint formula is and also know how to use it. Okay? But before we get that, let's rewind and let's have a think about what the midpoint is. Midpoint. Midpoint. What do you reckon that is? So we know it's got to do something with all these coordinate points that we've been using on our Cartesian plane. Hey, what could it be? I wonder if we have a look at this word, if we have a look at it, if we think about, okay, what is, when we say mid, what does mid mean? Obviously, when we hear mid, we think, right? We think middle, right? What about point? Well, when I hear points, in this case, I think of our coordinate points. Yeah? Coordinate points. But I know it's coordinate. I know it's only one. It's a coordinate point, not because it's a midpoint. It's not coordinate points, plural, because it's not midpoints, plural, okay? So just one. That's pretty interesting. So judging by and having a look at just the name of it, I know that I'm going to, my answer when I'm calculating a midpoint will actually show me the middle, or should I say the coordinate point in the middle. All right, so here's a graph I've prepared earlier. I've got 2 points, got points A, point B, makes a nice little line called AP, and I'm gonna find the coordinate point in the middle, yeah, or the midpoint for lack of a better term. So if we're having a look, I'm gonna zoom in here a little bit. I reckon it's, so this is AP, middle's what, around here ish. Let's give it a nice little thing here. There we go. X marks the spot, and I'm gonna put it M for middle, capital M, because we've already used lowercase m in our slope. Alrighty, and because it's the point between A and P, then I will call this the middle point, M, A, and P. And notice that this part here is a subscript. Yeah, it's the little one, it's a little baby one, just like how we have with our X1 and our Y1. This is a M, A, but it's not as obvious in this drawing, but that's okay, now you know. Alrighty, so having a look at this graph, I reckon this point here, it doesn't really give us a scale or anything, but I'm just gonna say that kind of looks like it could be 1, 1. So I'm gonna say, you know what, let's call this 1, 1. All right, now we are going to write the point here, and we know that our y value, yeah, the second value, remembering we have x and then y, so our y value here, we're noticing that it's not going up or down, is it? It's just straight across. There is no rise. It's just all run. So we know that there'll be no change in our y value, yeah? So no change means it'll just be the same as what it was on this first one. So I know that my y will be 1. So let's go and 1, close bracket. And I'm just going to pick a random number to go in here. And let's go 7. Cool. Alrighty. So I want to find out now, what is this point between, like what actually is this point? Where is it? What is its coordinate point? Yeah, I want to know what its brackety coordinate point parts are. Yeah, I want to know what these values are. Well, actually, you know what? I can already see something about this y. Hey, it's just like what happened about this one. It's still on that straight line. It hasn't gone up or down at all. So we actually already know what this one is. So let's just write down. This is just going to be 1, so that'll stay the same. So I need to figure out this one. So I know it's somewhere between 1 and 7. Somewhere between 1 and 7. So, you know what? I might even just go here and write 1 here and 7 here. It's going to be somewhere in between here, between 1 and 7. You know, I could just guess, I suppose. Like it could be, I don't know, like it could be like 3 or 4 or 5. Man, I don't know if it's really the right answer. Well, I know if it's 1 here, it's not going to be 2 because 2 is going to be too close and too far away from 7. Can't be 6 because it's going to be too close to 7, far away from 1. You know what? I do know how to find something that will tell me what is directly in the middle. And I bet you do as well. It's actually called something that you've seen before in statistics. It is called our average. Average. Yay. And that's where we add the two numbers together and divide it by add all your numbers together, however many you have, and then divide it by however many of those numbers that there was. In this case, we only have 1, 2 numbers, so we're just going to divide it by 2. So, you know what? Let's do that. Get this out of the way. So, my 2 numbers, I have what were they again? Oh yeah, 1 and 7. 1 plus 7 divided by 2 is equal to 8 divided by 2, because 1 plus 7 is 8, and I just rewrite my divided by 2 divided by 2. Now I have 8 divided by 2, which is 4. Awesome sauce. So I know that this here, this here is equal to 4. Alright, so I know that this midpoint, its coordinate points are 4 and 1. Okay, cool. That's our horizontal line. I want to do another line. Just bear with me while we have a little bit of fun with this. Let's make another one, and let's say I want it to be directly vertical. Oh gosh, what's happened there? This one, about there. I'm gonna call this point B. Alrighty, and I know, just as we did earlier, that because we went from here to here and we didn't change in our y value, our y'd stayed the same. If we're noticing here, we're going directly up, so we're not changing. There's no run, is there? We're not moving in our y. We're not moving in our x direction. Yeah, we're not increasing by x, we're not decreasing the x, it's just straight up. So we know that our x value will be exactly the same. So let's write that down, hey. 7, and I'm gonna pick a random coordinate point. Let's go 5. There we go. Cool. So now let's find the midpoint of this line as well. Let's go middles around here somewhere. So let's go here, and we'll call it M. But I've already used M, so I need to make it because this is MAP. Now I've got M, but I've got PB. So it's the line, the midpoint of the line PB. So big M and a little subscript. I'm going to zoom in and see if it can make it really easy to read. PB. I don't know. I don't know if that made it any better. Orchids. Alrighty. Now we want to find out what they are, what these coordinate points are, how do I find them, what is E? Again, I could try that weird value, but I know, how much easier was this one? Let's just do that again for the one we don't know. But we already know something, don't we? We already know what this one is. Because again, he hasn't changed, so let's just write this one in. How easy is that? All right, now we need to find the average of these ones, right? How much has it changed from here to here? So let's do that. We go, what was that numbers again? We had 1 and 5, so 1 plus 5 all divided by 2 is equal to 1 plus 5 is 6 on 2, which is equal to 3. All right, so I know that, ta-da, this point right here is going to equal 7, 3. So that means we just go over here. 3 will be about here. Yeah. This is about 3. We said this was 1. This is 5. Actually, you've said what this one was 4. Cool. It's my little graph. All right, there's a lot going on here, isn't there? I'll do one last one. Alrighty. So, I've made one last line. I haven't added any more points. So this is just the line AB. So my middle point that I'm going to pick here, I'm going to pick a middle point, which is around here. And I'm going to name it M. What do you reckon it'll be? M with little what's? Yeah, it is middle A and B. I hope you said that. You did, right? You didn't just sit there like, Miss, what are you waiting for? Like you're talking to nothing. What? You totally yelled it out. With enthusiasm. All right. So it is M, big M, AB. And the coordinate point here, want to figure out what that is. But first, before we do anything, hold on a minute. Can you see something? Is anything standing out to you? What can you already notice? Yeah? Do you see that? We already know what those values are. We've already found them, didn't we? We found them when we calculated these points earlier. Yeah? So we know here our x coordinate is what our x coordinate was here. So we know that this is going to be 4. And we know that our y coordinate, how high up, yeah, we know that we found that here. Right there. Here, it's that high up, which is 3. So I know that that's going to be 3. Now, that's all well and good, okay? But can you imagine how ridiculous that would be if I said, okay, here we go. You have a coordinate point and you have 2 lines here, and I want you to find the midpoint. Are you going to go through and like draw up the triangles and do this one, that one, and this one, and that one, and to do it all like, oh my gosh, no. That's way too much. Couldn't we just use something a lot easier? Like this? Yeah? Because isn't that, oh my gosh. You seen that? Hold on a minute. Can you see that this here is how we found this? and this one here. That's how we found this. That looks like a really, really, really easier way to do it. So you're telling me, Miss Page, yes, I am talking to myself in third person, that you can find out what that midpoint is just with those calculations, and I don't even need a graph or all these crazy things. Yes, Miss Page, that is talking to you. Yes, that is what I'm saying. All right, so let's write that down as a formula then. Let's do that. So if we're trying to find any midpoint, that is going to be equal to, well, we know it has to be a coordinate point, don't we? Yeah? Our answer is always a coordinate point. See, it's a weird one, this one, yeah? The rest of them, like our distance, was always just going to be a number, and our slope was just a number. But this one here, our midpoint, is a coordinate, because it's a point, midpoint, coordinate points. Okay, so I can literally just, what was this? This one was here, and then here I did these. So I found the average of these, which one was that one? My y value. So this is the average of the y values, and this is the average of the x values. So let's do this. So I know this is my x, and I found the average of my x. So this will be the average of x value. So if I have one x value, x1, and another x value, so my second x value, 2, and then the average is, you want to divide that by 2. All right, that's in the wrong spot, not enough room. There we go. And your other one, that's our x1. Your y is the exact same, but now it's the y values that we had. So to write that, so it's our first y value plus our second y value divided by 2 and close brackets, because our answer is a coordinate point. This whole thing here will give me my x coordinate point, and this whole thing here will give me my y coordinate point. Yeah, just like we saw earlier. Cool. So that, my friends, is the formula. So, long-winded story, that's our formula. That's how we get there. And let's go take this and write this up in our notes over here. Alrighty, so writing that down, we have, I might zoom this in a little bit so it's nice and neat. M is equal to, open bracket, the average of the x values for our x point, and the average of our y values for the y part of our coordinate point. Ta-da! Wonderful. And if we read the actual question of what it's asked us, it's not a question, sorry. It explains it here. So the midpoint is used to find the midpoint formula is used to find the midpoint between 2 points, x1, y1, and x2, y2. So any 2 points that you have in the entire world, you can use this formula here. And it's way easier. So let's do this example here. Let's do this first one. Alrighty. There's a couple ways you can do it. I like to use highlighters. You guys have probably noticed up here, I like to color code and say, okay, well, this is my x, so I'm going to put my x here, and this is my x, I'm going to put my x there. I've seen other people do it like where they just write, like they label it, and they say, okay, this is x1, this one's y1, this one's x2, this y2, and they can kind of follow it that way. So makes it easier for when you're substituting it. Whatever one kind of works for you, yeah? I like to color code because I like pretty colors. There's no right or wrong. Whoa, I don't even know what happened then. I must have cancelled something. All right, so let's do it. Given the midpoint, find the midpoint of GH given that G is this point and H is this point. So I've got these numbers, and I'm just gonna get my formula and substitute it straight in. So let's do that. M is equal to open brackets. Let's find out what my x's are. This is my first x value. So my first x value here. So I'll write that down as 7 plus my sorry, I just noticed it was like on the wrong side size pen, which is just weird. Alright, anyway. 7 we said it was. There you go. Plus our second one. X point. This is our second point, and it's the x value. Plus 9 all divided by 2, comma. Now we'll do our y values. Yep, we've done that. Our y1, so we're going to our first point, looking at the y value, -5, -5, plus, looking at our y2, going to our second point here, our second point, and looking at our y value here. -1. Right. All over 2. And close brackets. All right. Done. Easy. That's us putting it in, substituting it all into the formula, and it's easy days now. The rest is just computation, which we can even use a calculator to help us out with, which is easy peasy, but we shouldn't need to. So let's go. We have 7 plus 9. No worries. That's 16. So we got 16 divided by 2, comma. All right, this one's a little bit more tricky because it's negatives and stuff. Hey, I got -5. I'm in $5 debt, and then I add another debt of $1. God, I'm really bad at all these financial decisions today. So $5 debt, add more debt, another $1 worth of debt. I'm in $6 debt now. Oh gosh. Somebody take my card off me. There we go. Cool. Next part. It's not quite finished yet, just because these are kind of ugly. It's no number. I can't really find that on my Cartesian plane, can I? No. So, let's simplify it further. All right. 16 divided by 2 is 8. 8. And -6 divided by 2 is, I know 6 divided by 2 is 3, but I also know that a negative, and it was negative, just ignore all of that whole thing that I said here. Alrighty. Alrighty, last line of working out. M is equal to we need to simplify this, which is 16 divided by 2, which is 8. Simplify this, negative 6 divided by 2. I can put that on my calculator, and that'll give me negative 3. Okay, and we expect that because negative 3 times negative 3 times positive 2 gives us negative 6. Alright, all goods, all goods. Fantastic, that's our midpoint. Ta-da! That's all it is. Look at that. How cool is that? Easy peasy. Alright. One last example on this one. Alrighty. Find the midpoint of AB, given that A is the coordinate point at negative 7, 4, and B is the coordinate point at 3, negative 4. Okay, well, let's write down the formula, because otherwise I'm going to forget the order of everything, which I have done in the past. So x1 plus x2 then y1 plus y2 average. There. Alrighty, so substituting. Let's look at our x1. Well, our first point is over here, so this will be our x1. So that will be negative 7. Oh my gosh, what's my working out doing? I'm missing the rest of everything. Where's my m equals? M equals open bracket. There we go. Remember, when you're substituting your values in, you're just rewriting the whole thing that you have here and then changing the variables. Yeah, you're changing the x's and the y's out for what you have. And you need to make sure you're rewriting everything else. Otherwise, it's just then you just write words and not sentences. You know what I mean? Like math words. All right, x2. Well, second point, x value is 3 divided by 2. Now looking at our y1 is 4 plus y2 divided by 2. There we go. Awesome. Now just a bit more computation. If I had $7 debt and pay off $3 debt, I only have $4 of my debt left. Divided by 2. Come on. And then if I have $4, but then I gain a $4 debt, well, I ain't got any money, do I? I've got no money. Divided by 2. Which is really funny if you think about it, because isn't no money divided by 2 just no money? Because you can't separate 0, nothing into halves. You can't, you know? So that actually tells me my answer here for my y part here, which is just 0. Anyway, we need this part. I'm getting it all out of order. It's all weird. Why did I do it that way? Negative 4 divided by 2. Negative 2. Alrighty. That's your final answer. Hurrah! We have done it. We've finished it. Alrighty. Fantastic. So, at this point now, you should be able to look at your midpoint questions that you have on that same piece of paper that you were just doing all your distance ones on. You can practice all of that one on there as well. So I definitely want you to go back through and have a bit of a practice. Try all those questions. Make sure you're showing all your working out, because your points, your marks in your exam are based on a lot of your points in there. Okay, you're working out your points in your exam for your marks. All right, awesome. Once you've finished that, you can then work on your exit ticket. I'm not going to go through this exit ticket with you, but I want you to write it down in your books, and I want you to actually let me know. Okay, but yes, I want this feedback. I'd like to know what you enjoyed about it, anything you found interesting, or anything you're still not sure of and might need help with. Okay, main takeaway point is I need you to know what each of these formulas are used for, when to use what are they. All right, on your exam you will be given these formulas. Okay, they will be given to you. They're not going to tell you what they are, and they're not going to be given at the question. It's going to be given right at the front of the exam, and you're going to have to go and figure out which one to use when. All right, so make sure you know that. Make sure you're confident figuring it out and when to use it. And if we go back to our our success criteria stuff, we've practiced a thing, we went over our distance, and we just finished looking over our midpoint formula. All right, hopefully you're doing this on your own, because practice makes perfect. And then after you do that, please then practice that exit ticket review, because you need to make sure, hey, that's cool. You need to make sure that you can recognize and identify those formulas. And you also need to be able to calculate the slope, the midpoint, and the distance. Okay, you need to know these for your exam. Legit. Speaking of which, you have been sent your revision sheets previously. All right, I've already emailed them to you. You have them. All the questions that are on your revision sheet will have equivalents of those questions on the exam. So make sure you are confident with your revision sheet. Because if you know you can do your revision sheet, then no worries. Easy peasy. You've got it. You're killing the exam. All right. Monday, we're going to be going through that revision sheet with any questions that you have. So that means by Monday you need to make sure you've actually had a little bit of a go and tried those things out. Hopefully you've done that by now. All right. I want you to come to the session with questions so we can get straight into the loosey-goots parts of it. All right, because your exam is on Thursday. Anyway, thank you so much. See you next week.